In today's video, we will be introducing our study of motion by talking about what motion is and the difference between distance and displacement. So motion, moving, to move, these are words that we use all the time in our day-to-day life. But when we're talking in the context of physics, what actually is motion? Let's look at a couple examples of motion to sort of get ourselves thinking. Here we have one very obvious example of motion with this car speeding down the road and careening off into the guardrail. Here we have a friend, maybe not so good of a friend, throwing a ball and hitting his friend in the head. We can see that the ball's moving, the arm is moving. We also can see that the friend's head is definitely moving when he's hit with the ball. Here we have the earth spinning on its axis, rotating around and around constantly. Another example of motion. Dancing alien, hitting some sick moves. He's not going very far, but he's definitely seems to be in motion in some way. Another example of very slow motion, but still motion with this snail slowly but surely making his way to the finish line of that race. And finally, we see Perseverance 2020 landing on the surface of Mars. Lots of motion happening there. So as you look at these examples, were you able to come up with a thought of what you think motion might actually be defined as? So in physics, when we say motion, it is defined as any change in an object's position or orientation. That means if an object is to move positions from one place or one point to another, or to change its orientation in any way. So to change the way it's facing or the way it's positioned. These define motion. So now that we know what motion is, let's talk about a couple of terms that we're going to be using in order to describe and explain objects' motion. First, we have distance. Another word that we use often, but what do we really mean when we say distance? Pause the video again and see if you can come up with your own definition. So when we're talking in physics, distance describes the amount of space between two objects or 2 points, or how much ground or how much space an object has moved over the course of its motion. The units for distance are the meter, which is abbreviated lowercase m, or the kilometer, which is abbreviated lowercase km. 1 kilometer is equal to 1,000 meters. Let's look at a couple examples of distance. So first, we have a very obvious example here of 2 points in space and the distance between them. We can see that this dotted line quite simply represents the space or the amount of space in between these 2 points, representing the distance between them. Another example we can see here is the distance that this biker might travel if he were to take these 2 different paths. So if we look first at the red path, where he bikes from the tree at point A, goes home, and then to the tree at point C, we can see that on the first leg of his travel, he covers 4 meters of distance, and on the second leg of his travel, 3 meters. That means that his total distance covered was 7 meters. We can also say that the distance between point A and point C, or the distance between those 2 trees, is 5 meters, represented by the black arrow. Here we have a diagram representing the distance between our planet Earth and Mars. This is a distance that's constantly changing based on the rotation of Mars. But while these planets are at their very closest point, they are 55 million kilometers apart. At their furthest point in Mars's orbit, Mars is 400 million kilometers of distance away from Earth. Next, we'll talk about displacement. This is a term that can easily get confused with distance, but has a very specific difference. Displacement, on the other hand, describes the space between an object's initial position and final position over the course of its motion. This means it is the shortest straight path between the point that the object started at and the point that it ended at. The units for displacement are also the meter and the kilometer. Here we can see our same example, but now we can sort of make a little bit more sense of this using both terms that we've just learned. So we can see, just like we talked about with distance, the red arrows, or the travel from point A through the house at point B and back to the tree at point C is 7 meters of distance being covered. However, if we were to want to know the biker's displacement over the course of that motion, it would not be 7 meters. Instead, it would be 5 meters, because we can see that the shortest straight line between his starting position at point A and his ending position at point C is that straight line of 5 meters. Here's another similar example where we can see if any object were to move along that curved black line from point A to point B, the length of that curved path would represent the distance covered. However, the displacement of the object would be represented by that straight blue line, again showing the displacement, or the shortest straight path between the object's starting position and its final position. Here's another very similar example where the bee could buzz around in circles, flying every which direction. That entire dotted line path would represent the distance that was covered or was traveled by the bee, whereas that straight pink line would represent the displacement, or how far the bee has moved from its initial position. Finally, we'll look at that first example again. We see that the dotted line from point A at the bottom left to point B at the top right represents the distance between the 2 points. Here I'd like you to pause and try to find out if you can decide what would be the displacement of an object if it were to move from point A to point B. If you paused and thought about it, hopefully you came back and said that the displacement in this example would be exactly equal to the distance. That is because the path of travel actually is already the shortest straight path from point A to point B, meaning again that the distance in this example is exactly equal to the displacement.